Hello! In this class we've learned the many topics covered under differential calculus. One topic we have yet to cover is the brief beginnings of calculus. The history of calculus may seem like a dry topic, but let me introduce you to a time of inspiration, discovery, controversy, and nationalism. Welcome to the Calculus Wars. So where did calculus begin? It's unknown who devised the first complicated mathematical formulas. People argue between the Egyptians, Babylonians, or Greeks. However, calculus as we know it began in the 17th century. We all know the story of Isaac Newton with his apple. But Newton ran into a problem. When he was trying to describe how an object falls, there was no mathematics at the time that he could use to describe an object at any moment of time. So between the years of 1664 through 1666, Newton developed the first forms of calculus. He called it the methods of fluxion, and a fluxion is what Newton called the derivative with respect to time, or x prime. Here's a basic problem in calculus. We will find the derivative using Newton's method. First, you solve for 0. Okay, that's easy. But now you plug in x plus x prime naught into all x values, and y plus y prime naught into all y values. Okay, this equation is a bit more ugly, but just wait, there's more. Now subtract the original equation from the new equation, like this. And now you solve for y prime over x prime. While very ugly, it will eventually work out. However, Newton was very nervous about how the scientific community would view his work, so he refused to publish it. Gottfried Leibniz, who has majestic hair, began his work on calculus between 1672 through 1676, meaning Leibniz finished his work on calculus 10 years after Newton's method of fluxion. Leibniz saw calculus in terms of sums and differences. Leibniz would introduce integral notation and also create the word differential to describe his work. Using the same equation as before, Leibniz discovered the power rule and that the derivative of a constant is 0. So he would simplify this equation to look like this. As you can see, Leibniz's method was much more efficient than Newton's method of fluxion. So what are the calculus rules? It began by Leibniz publishing his findings in 1684. Newton saw his work and was furious. To Newton, Leibniz has stolen his work, even though Newton had never published his findings. Newton published his work in 1693, but at first, the two scientists limitedly acknowledged each other's works. At first, everything was peaceful, but then scientists began to choose sides. L'Hopital of France chose Leibniz's side. Nicolas Dulier of Switzerland chose Newton's side. And it was Dulier who would fire the first shot of the war. In 1699, Dulier would accuse Leibniz of plagiarism of Newton's work. Throughout the scientific community, mathematicians took sides and would fight for Newton or defend Leibniz. Newton's followers, who were almost entirely British, said that any responsible mathematician should doubt Leibniz as the discoverer of calculus because he stole Newton's work. Leibniz's followers would attack Newton's personal character, saying that Newton acted like a mob boss who would order his followers to attack the mathematicians who supported Leibniz. By now, the war was in full swing. But in 1711, mathematicians would finally desire an end to the conflict. They would take the case to the court of the Royal Society. But guess who just so happened to be the president of the Royal Society? That's right, Isaac Newton. His sentence would be that he'd be dishonored from the scientific community, and he died in 1716 believing that he would be remembered for his dishonorment. Due to nationalism, Britain would continue using Newton's method of fluxions. Continental Europe would use Leibniz's method because of how easy it was to use. While this may sound like a choice of mainly preference, Newton's method was so poorly done that it's believed that Newton's method is the reason to blame for Britain being mathematically inferior to continental Europe for the remainder of the 18th century. The calculus wars ended with the death of Leibniz, and he still remains in the shadow of Newton to this day. However, I believe we should remember Newton as discovering calculus, and Leibniz as perfecting calculus.